Hello, hello. Here are the solutions for the core part of the trig mock exam. Um, so here's a problem that was worked out by Nicole, and there were a couple problems with her work, and you're supposed to find the problems that she had. So maybe one of the best ways to do one of these problems is to work it out yourself and then start to see what she did different than you did. Hopefully, you will have the right workings, and when you compare it to hers, and it'll be obvious what she did wrong. So when I look at this triangle, I want to find this side. This side is opposite from the angle. So this looks like I'm going to be using opposite over hypotenuse, right? Because those are the two things we know. We're not going to use adjacent because we don't know it and we don't want to know it. So that leaves me SOHCAHTOA with SOH, right? So the sine of 61 degrees is going to equal x over the hypotenuse, which is 52, right? Which is O over H. And then I'm going to use my calculator, find sine of 61. Sine of 61. Oh, whenever you turn on your calculator, make sure you are in degree mode. Degree mode. And then I'm going to do a quit, and then I'm going to do a sine of 61 degrees. That gives me 0.875. Usually it's kind of customary to keep the first three digits of sine, cosine, tangent. And then I have that, and then I'm going to multiply both sides by 52 to get x by itself. So 0.875 times 52 is equal to 47.2. Okay, so let's compare that with what Nicole did. Okay, so, we have sine, she has cosine, so she had a problem there. Okay, so she should use sine, not cosine, because it's opposite over hypotenuse, right? And then let's see. So then, and then there's another problem. Look, if it was cosine or if it's sine, look, we have x over 52. She has 52 divided by x. So actually, this should be x divided by 52, not 52 divided by x. Okay? And so if this was changed to sine and this was reversed, then the rest of the problem will be worked as we have there. Okay? All right. Next problem. Find angle A if this is your triangle here. Angle A is this angle here. So this side is the opposite, right? It's the opposite of angle A. This side here is the adjacent. It's next to angle A. And this is the hypotenuse. The hypotenuse we don't know, right? And we don't want to know it. So we could just ignore the hypotenuse. So basically we're left with opposite and adjacent. We know that SOHCAHTOA, the trig relationship that involves opposite over adjacent, is tangent equals opposite over adjacent. So let's use that one. So the tangent of angle A is equal to opposite over adjacent. It might be a little confusing that we have two A's here, but one of these is adjacent. I'm going to write adjacent just so it's more obvious. So tangent of A, we don't know what A is, but we want to know. Opposite is 60. Adjacent is 35. Let's divide that out here on the calculator. 60 divided by 35, 1.71. Now how do we find angle A? We're going to have to take the inverse tangent of both sides. Inverse tangent of tangent cancels out. So we want the inverse tangent of 1.71. Second tangent is inverse tangent of 1.71 gives me 59.7 degrees. So A is equal to 59.7 degrees. Okay, let me check that answer, make sure it's right. Yeah, it is. Okay. Next question. Here we have a lot of unknown angles. We want to know all of these angles, okay? And we have known sides. We have 12 centimeters known for this side. The height is 14 centimeters, and the hypotenuse here is 23. Let's figure out all these angles. Well, the best thing to do when you have two triangles stuck together like this is to separate them into two different triangles and then try to see which one you solve first, because whenever you have two triangles, you're not going to do both of them at the same time. You're going to figure out which one you know more about and try to solve that one first. Well, look at the yellow triangle. You have two unknown angles. One of them is 90 degrees, but that doesn't help too much. You have two unknown angles and one known side, no, two known sides, okay? And then the red triangle, you have two known sides and two unknown angles. So in this case, you're kind of tied, right? The yellow triangle has about as much information as the red triangle. You could do either one first, okay? So how about if we just do the yellow one first, because that one is on the left. So I'm going to say, let's see, I'm going to do W first, okay? So I'm going to work with W. Which trig relationship relates W to these two sides? So 14 looks like it would be the opposite side. 12 looks like it would be the adjacent side. So I could do a tangent of W equals opposite over adjacent, the opposite being 14 and the adjacent being 12. So I could take 14 divided by 12 on the calculator. 1.17, and then I'm going to take the inverse tangent of that to find out what W is going to be. 49.4. 49.4 degrees. Okay, that's what I think W is. And once I know W, I don't have to do any fancy trig to find X, right? I know that the three angles of this yellow triangle add up to 180. So I could say that angle X is equal to 180 minus 90, which is this angle here, minus W. Okay, so that would be equal to 90 minus W, which is 49.4 degrees. So X is actually equal to 40.6 degrees, right? Okay, so that's angle X. All right, so now we just need to find angle Z and angle Y, and we could do a similar thing that we did with the yellow one. We have two known sides. Let's look at angle Y first. So looking at it from the point of view of angle Y, we know the opposite and we know the hypotenuse. Opposite and hypotenuse, that would be sine, right? It would be the sine of an angle is equal to the opposite and the hypotenuse. The sine of what angle? Angle Y. And the opposite in this case would be 14, and the hypotenuse would be 23. So I'm going to put 14 divided by 23 in the calculator, and I get 0.609, and then I'm going to take the inverse sine of that, and I'm going to get 37.5 as my angle Y. Okay? And then now that I know angle Y, I can find angle Z easily, because angle Z is just going to equal to 90 degrees minus Y, right? Because the three angles are going to add up to 180 degrees, and one of the angles happens to be 90. So 90 minus 37.5 is going to give me about 52.5 degrees. Okay, so that's angle Z. Angle Y is that, okay? So we got this, we got this, we got this, we got this. Okay. What is the length of side A of this triangle here? We have this angle, and we have this side, and we have this side. Even though we don't know this side, we want to know this side. So what is it? It's the opposite from 15 degrees, right? And this would be the adjacent of 15 degrees. So opposite, adjacent, that reminds me of tangent, right? Because TOA. So the tangent of 15 degrees is equal to A over 21, the opposite over the adjacent. Tangent of 15 is 0.268, and I'm going to multiply that times 21, and that gives me 5.6 for my length of A. Okay? All right. Moving on to the next page. It says here that for these pages, we're going to work to find the answer of angles to the nearest degree and distance to the nearest tenth. Okay, so here we have a two triangles stuck together again. And this time we don't know this height and we don't know this hypotenuse. It's saying that CD is a flagpole and that two children, Amber and Billy, are looking at the top of the flagpole and they have an angle of elevation of 30 degrees and 45 degrees respectively. So we're going to calculate the distance that Billy is from the top of the pole, which is distance A. Okay? Now, if we divide this one into two separate triangles, a red triangle and a yellow triangle, now it's not like last time where both of the triangles had an equal amount of information. If you look at the yellow triangle, we don't know the height, we don't know the hypotenuse, all we know is the angle. So we can't use any trig to figure out any more information about the yellow triangle yet. Look at the red triangle. The red triangle, we have an angle and we have the hypotenuse, we just don't know the height. Looks like we have a chance to find out the height there if we relate these three. So the angle is the opposite to the height. And then we also know the hypotenuse. So it looks like this is a good candidate for sine is equal to the opposite over hypotenuse. The sine of what? Sine of 30 degrees is equal to the opposite over hypotenuse. The opposite being h and the hypotenuse being 20. Sine of 30, you may recall for extension people, is 0.5. So we don't even need to put in the calculator. But if you do, go ahead and type it in the calculator and make sure that sine of 30 is indeed 0.5. Now I have h over 20, multiply both sides by 20, I get h equals 10. So our flagpole height is 10 feet. And then once we know that h is 10 feet, now it becomes easier to do the yellow triangle, because the yellow triangle we have one angle and we have the opposite side, right? We just don't know the hypotenuse, which we do want to know. So let's write that relationship. We're going to write sine of 45 degrees is equal to h over the hypotenuse. H we already know happens to be 10. Now we're going to put a in the numerator by doing cross multiplication. So we'll do a sine of 45 is equal to 10. A is equal to 10 divided by sine of 45. Sine of 45 degrees is, my physics teacher in high school used to always say, sine of 45 degrees is his favorite airplane, which is the 707. I don't even know if that's a real airplane, but he would always say that. That's one of the angles that physics students will always end up memorizing because they have so many problems where the angle is 45 degrees. The answer is 14.1. Okay? All right, so that was the answer for 5, and those two heights and lengths are in feet. Number 6, from an airplane at an altitude of 1,200 meters, the angle of depression to a rock on the ground measures 28 degrees. Find the distance from the plane to the rock. So we got a plane, and we got a rock, and we know that the angle of depression, which is just imagine the pilot looking straight ahead, minding his own business, and then he decides to look down at the rock. When he looks down at the rock, his eyes are going to follow this angle down. That is called the angle of depression, which is 28 degrees, okay? And we are looking for the distance from the plane to the rock, which is going to be this distance here. And so we have this triangle. Do we know any other information? Yeah, 1,200 meters is the height. So this vertical is 1,200 meters. And what relationship is going to relate this angle with this opposite side and with this hypotenuse? Well, that would be right? So it would be sine of 28 degrees is equal to the opposite, which is 1,200, divided by the hypotenuse, which is x, okay? And then I'm going to cross multiply and put x in the numerator, and then I got that. And then I can divide both sides by sine of 28 to get 1,200 divided by sine of 28 degrees. And now I'm going to divide that out on the calculator. 1,200 divided by the sine of 28 degrees is equal to 2556. Let's check this answer to see if it's right. Yes, 2556.1. Okay, and that's meters. That's the distance to the rock there, okay? A lot of people made a mistake of saying that this angle is 28 degrees, but the angle of depression, just remember that the pilot needs to be looking straight ahead, and the angle of depression is the angle that his eyes are going to lower through. 7. Determine whether or not you can use the law of sines, and if you can, solve the problem. If you can't, explain what information is missing, okay? Some people looked at this problem and said, well, I know that this is 120 degrees, and I know that this is 22, and I know this is 22, but how on earth am I supposed to figure this out? Well, if I'm going to use law of sines, that means I have to know one opposite side angle pair, and I know none. But one thing you do know is that these two angles here are equal angles, right? Because there's several ways you can figure that out from your past history and geometry. But maybe the easiest way is that this is a regular polygon, so this is all symmetrical, so those two angles will be the same. So if we know that these two angles are both x, then we could say that 120 degrees plus x is equal to 180 degrees because three angles in a triangle add up to 180 degrees, right? So 2x is equal to 180 minus 120, which is 60 degrees, so x is equal to 30 degrees. So each one of these angles here, x happens to be 30 degrees. So now we have a problem that we can solve with law of sines because we have 30 and 30 and we have 120. So we know all the angles, plus we happen to know two of the three sides. So remember that if you have a relationship, a triangle, where you know the one opposite angle side relationship, then that means you can figure out all the others, and we do know that. Okay, so now we just need to figure out this length FB. So on the exam, we're going to give you the formula for law of sines. I guess most of you just figured that out by yourselves. But we have our choice. We have the one where the angle's on top, and we have the one with the angles on the bottom. Which one is easier to use? Well, if you happen to be looking for a side length, then it's easier to use it when the side lengths are on top, because then you don't have to do any cross multiplication. So let's do that, okay? So let's do side 22 divided by the sine of 30 degrees, and we're going to make that equal to FB divided by the sine of the angle opposite FB, which is 120 degrees. Okay, and then we're just going to multiply both sides by sine of 120 degrees. Sine of 30 degrees equals FB. Okay, so let's just multiply all this out on the calculator. We're going to have 22 times the sine of 120 degrees divided by the sine of 30 degrees. Okay, what do I get? I got 38.1. Okay? And that is correct, I think. Yeah, it is. Okay, so now we're going to go down to the last problem. All right, let's see. We are going to figure out some of these unknown lengths, and I'm going to mark the ones that we want to know. We want to know FG. We want to know ED. We want to know EF. And we want to know angle FDG. FDG is this angle. And we also want to know the angle EDF, which is this angle here. Okay. Let's see. Just looking at this triangle, I can see that this angle here is 180 minus 125, right? 180 minus 125 is about 65, is that right? No, it's 55, right? 55 plus 125 is 55 plus 125 is 180 degrees. Okay. So if this is 55 degrees, then we know that this angle here is 90 minus 55 degrees, which is 35 degrees. So we just got one pretty easily, didn't we? Maybe we can get the sides too, because now we know that the angles here are 35 and 55, and we also know the hypotenuse is 20, so we can figure out these two unknown sides pretty easily, right? So how about if we just use regular trigonometry? We're not even going to use law of sines or anything to figure out DE and EF. Let's see. So let's look at it from the point of view of 55 degrees. We know the hypotenuse, and we also know we want to know the opposite. So let's say the sine of 55 degrees is equal to the opposite over the hypotenuse. So the opposite is this unknown length DE, and the hypotenuse is 20. And then that's equal to the sine of 55. Well, what is the sine of 55? Sine of 55 is equal to 0.819. Okay, and then so DE is equal to 0.819 times 20, which is equal to 16.4. Okay, so we already found DE, and now we just need to find EF. Well, EF we could figure out with the cosine, right? If we know the cosine of 55, that would be the adjacent of the hypotenuse, the adjacent being EF, which we don't know yet, and the hypotenuse being 20. So what is the cosine of 55? Cosine 55 is 0.574. 574 is equal to EF divided by 20. So EF is going to be 20 times 0.574, which is 11.5. Okay, so we got quite a few answers now. Let's write some of these down. So we have 16.4 as ED. We have 11.5 for EF. And we have 35 degrees for the angle EDF. Okay, and now we just need to know these last two remaining side and angle. Looks like we could use law of sines for this, okay? There's other ways to do it, but since we're doing a law of sines chapter, let's do it with law of sines, okay? So we know that this side corresponds to this angle, and we know that this side of 20 corresponds to this angle here. So let's try to figure out this angle here. They didn't ask us for it, but once we figure out this angle, then we can figure out this angle, right? Because all the angles are going to add up to 180. Okay, if you don't know what I'm talking about, just like it's going to help us. If the more angles and sides we figure out on this unknown triangle, the better. Okay, so let's do this. We're going to use the law of sines formula that has the angle on top. We're going to use this one here. Okay, in fact, why don't I just like copy it over there? Copy, paste, and I'm going to make it a little smaller so it doesn't take up so much space. Okay, so I'm going to have sine of 125 degrees divided by 30, because that's the pair that we know, right? And then I'm going to make that equal to the sine of this unknown angle. I'm going to call it sine of G, divided by the side 20. And then I'm going to multiply this one by 20. I'm going to multiply both sides by 20. And then I'm going to say that, hey, that's going to be equal to sine of G. So let's figure it out. We're going to have 20 divided by 30, which of course is 0.667. And then I'm going to multiply that times sine of 125. And that gives me 0.546. So 0.546 is equal to the sine of G. So what is angle G equal to? It's the inverse sine of 0.546, which is 33.1 degrees. Okay, now we know that this angle here is 33.1 degrees, but they didn't ask us for it. Why did you do that, Mr. Tsubaki? Well, if I know that this is 125, and I know this is 33.1, and I just don't know the third angle, guess what? They add up to 180 degrees. So I can just do 180 minus 125 degrees minus 33.1 degrees, and that'll give me the unknown angle, which is 21.9 degrees. Okay, so now I can write down over here And we don't need to know 21.9. 22 is fine, so I'm going to put 22 degrees for the unknown angle. And then all I need to do now is to find this side. And once again, I can use law of sines to do that if I want to, because I know that sine of 125 divided by 30 is equal to sine of 22 degrees divided by FG, right? And let me cross multiply so that I can get FG in the numerator. And so I'll have FG, 30 sine of 22, and then here I have the sine of 125 multiplied times FG. Now I'm going to divide both sides by sine of 125. I'll get 30 times sine of 22 divided by the sine of 125. And then I'm going to use my calculator to multiply that out. I'm going to have 30 times sine of 22 divided by, sine of 125. And I get 13.7 for FG. Okay, so those answers look okay. And that was the last problem. There's other ways to do that problem. You could do it with Pythagorean's theorem. You could do it all with right triangles and not do any law of sines, but I did it with law of sines because that's what's fresh in mind. Okay, don't think, if you got the right answers, then your way is fine.